Hi, today I'll be talking about Math.rint and Math.round. Now, these are fundamental concepts in computer programming, and I'm going to be talking with respect to Java. So, first of all, let's start. What's Math.round and Math.rint? Are they like procedures, or are they some syntaxes, some errors, maybe some pieces of code which lets you code a virus? No, they're nothing like that. They're simply methods, right? A method is a program module used at different instances in a program to perform a specific task. And like this is a very complex definition, so I'll explain it very simply. A method lets you do a task. Suppose like you wanted to make a cake, so you could write in a computer language, please make a cake. Okay, and like that you call that a method in computer programming. And methods and functions are the same thing. So like I had an incident where I knew these two guys, and one of them was like, hey, I learned a method in Java. And the other, he saw a girl nearby, so he was trying to impress her, and he said very loudly, bro, but I learned a new function in Java. And the girl, fearing it, their mental state, just ran away. Okay, so let's get back to the topic. So now we're talking about round and rint. These are two methods, and they help in rounding values passed as a argument by user. They accept a single value and return a single value. And the return data type for round is integer or long. Now, what is a data type? A data type will tell you that how your value is going to be, like what is the nature of your value. For example, if you put your value as C, so what is C? It's a character. If you put your value as A, again it's a character. If you put your value as, suppose, a name like Rahul, so then that's a string, okay, meaning a bunch of characters. And suppose if you take a value like 12, then that's an integer, right? And another uh, value like 40.2, we would not call that an integer, we would call that a float or a double value, right? So the return data type for round is integer, which means that the answer it returns will be in the form of this, like 4.0, 5.0, right? And for rint it's double, meaning 4 and 5. For rint it's double, so meaning rint will return outputs like 4.0, 5.0, etc., right? Now I raise a question, are math.round and math.rint actually methods? Well, actually they aren't. Okay, because you see the syntax of a method. And what is the syntax? First of all, syntax is a general way of writing something, and we call that general way of writing in computer language syntax. Okay, so this modifier, return type, method name, data type, variable data, and you won't understand this. Okay, you'll be like, what is this? Like, what is this? Modifier, return type, what? Okay, so modifier actually means like it tells more info about the function. Like modifier can be static, right? And return type tells what the function will return, what the method will return when you feed something into it. Like suppose the method can be thought of as a machine, okay, and you feed like some cloth in it, okay, and that machine returns socks. So what is socks? Socks is the return type, okay, and cloth is what you fed to the machine, and we call that cloth data type and variable. Basically we call it variable. Data type is defining what that variable is, so we call that cloth a variable which you are like passing to a function, right? So that function returns a socks. And method name, so that's simple, that's self-explanatory. Like everything has to have a name, right? You have a name, I have a name, and even in computer programming things have names. We call them identifiers, but let's not use that term. Let's not get too complex, right? So this method name, right? So data type variable, what does data type variable mean? Data type means that what type of a variable it is. Like I told you, data type can be int, float, double, char, and int would be 1, 2, 3, double would be 1.004, 1.34, 2.67. Okay, character can be C, D, A, right? So that's the data type. And a variable, what's a variable? A variable is basically a storage location, you can say. It's like, think of it as a box which stores things, right? So that's a variable. Now method body, like, okay, this is just this is what is written inside the method. Because if you want to do like if you want to bake a cake, you'll have to write, right, that add water, add sugar, do this, do that, put it in the oven, right? So that would be your method body. Okay, so like this is the general syntax: modifier, return type, method name, data type variable, data type variable, and method body. Okay, but compare this method syntax and now compare these two statements, math.round and math.rint. Do you even see any similarity between this and this? No, right? So why did I say that math.round and math.rint are methods? Well, actually, in layman's terms, we can call them methods, but actually math.round and math.rint are not really methods. So let me explain that, right? See, now this is the actual way how math.round is written. Public static int round float a. She'll be like, oh my god, what is this? Like, what is this? What has come out of the picture? So, like, you don't really need to know what this means, okay? This is actually a static method, okay? Meaning it doesn't have to be invoked in the main method. It can be called automatically without an object, but let's not get into that, right? So math.round is actually this method, but we just write it as math.round because if you see this method, like writing this method, it's so long, it's so complex. Who would want to write so much, right? So we simply just write math.round. And another way of writing math.round is public static long round double A, right? This means, like, what's the difference between these two? What's the difference between these two? See, this one takes a float as an argument. And what do I mean by that? Meaning this one will take 4.22 something, right? This one will take 4.22 as an input. And what will it give as an output? It will give an integer value. An integer value meaning like 4. Okay. And now this one, this example, what it does is, like, you have your machine here again. It takes an input like 4.3456789, very big, because double and float that's the difference, that double is very big and float is a bit smaller to say it in layman's terms. Okay, but it's actually more related to the memory when I say it like that. Anyways, so like when you input this number, it will return a long number. Okay, so like 4. How we said that double is bigger than float, similarly long is bigger than int. So when you have much bigger values which you cannot fit in an integer data type, you will use the long data type, right? Okay, now what is the way of writing math.rint? The actual way of writing it, it's public static double rint. Okay, and we don't need to get into what this means. I just put this for like extra information, because like it's a confusion that is math.round and math.rint actually a method? No. So then let's answer the question, what exactly is math.round and math.rint? Okay. Okay, so you see this. This is your method. Then you will ask, what's this? This is actually a class. Okay. And a class is a collection of objects, methods, and variables, right? So this is a class. And what's this dot here? Is this just some random dot, or like something else entirely with the name Tampu, Baplu, Champu? No, no, no. Actually, this we call it the dot operator. It's a very beautiful thing, the dot operator. I'll explain the dot operator with an example. Like suppose you have a family of 10 and you're going to the mall, right? And you lose one of your cousins, okay, in the mall. So what will you do? Go screaming like a madman, hey cousin, hey cousin. No, no, no. You'll go to the that speaker, like where they make the announcements about shoes, about clothes, about undies, right? So you'll go there and you'll say, hey cousin ABCD, I'm looking for you, please meet me at this place, right? So what have you done here? You have called him or you have invoked him. You have called him or you have invoked him. And what does the cousin belong to? The cousin belongs to your family. So basically, what I'm trying to say here is that round is like your cousin, which belongs to a family, and that family is called math. Okay, and we don't call it family, we call it class, right? And उस class का नाम is math. The name of that class is math, right? So round is a method which belongs to math class, and this dot operator, it is like a telephone with which you can phone, with which you can phone the members of that class, with which you can call or invoke the members of that class, right? So this is how we write, and it's same for Math.rint. Okay, so actually, what we're doing here, these are not methods, these are rather declarations. Like, we're actually invoking the members. These are not methods, but for layman, in layman's terms, to avoid, just to avoid the complexity and make it simple, we call them methods, right? And suppose you were in a mood and you're like, no, but I want to import the math class in Java. So how would I do that? Right? Like, you're like, why not? Let's just write an extra line. So we can do that by writing import java.lang.math. And what is this java.lang.math? Okay, so math is a class and lang is a package. Okay, and what is a package? See, now I told you that a class is like a family to which methods and functions belong, right? So when we take multiple families which have the same ancestry, we can place them together, right? If they have the same ancestry. So like that, multiple related classes are known as a package. Okay, and we call that package lang. I mean, this package which has math class is called lang. It contains a lot of classes. See, math is not just the only class in this package. Okay, there are many other classes which help you in they're basically default classes which are easily available within the program and which you don't have to import. So this statement is pretty useless because this class is already included in the program. Okay, but I just mentioned it if you were like in a mood. Okay, so now we'll start the story of Math.round and Math.rint. Okay, so the first number which we will encounter is numbers which are like 2.4, 3.2, 1.1. You get what I'm saying? Which have their fractional part, that is their decimal part, less than 5. What did I say? Their decimal part is less than 5. Okay, what do I mean by decimal part here? So let me take an example. Let's say 7.6. Okay, so what would we call this? I will call this the integral part. You could also call it the whole part, the number part. But for now, for just the sake of simplicity, I'll call it the integral part, right? And this 6, I'll call it the fractional part. Okay, so just remember this point, that I will call this the integral part, this the fractional part. So here, when I mean for numbers below box 0.5, I mean like you can put any number here, but the fractional part of that number will be less than 5. The fractional part will be less than 5. So here you can check 2.4. 4 is less than 5, correct? 2 is less than 5. 1 is less than 5. 1 is less than 5. 3 is less than 5. 4 is less than 5. So we are considering these numbers. Okay. And I have divided these numbers into two cases, one for positive and one for negative, right? So positive numbers include 2.4, 3.2, 1.1, right? And in 2.4, you can easily see 2 is the integral part. And what is 4? 4 is the decimal part. So 2 is the integral part. So when you execute this, when you write Math.rint 2.4, Math.round 2.4, and you write it in your IDE, okay, your IDE, meaning the place where you program, right? When you write it there, Math.round, Math.rint, you'll actually see that the answer you get is 2. Okay, And I took some other examples. I took 3.2, I took 1.1. Same thing I am observing, that it is only returning this part, right? I mean for positive, I'm talking about positive right now. So that means that in general, rint and round return integral part, meaning that rint and round, the two functions which we are talking about, when you give them numbers which are like this form, like 2.4, 3.2, 1.1, they will return this part only, the first part. Matlab the part which is the integer. The second case which I include is for negative numbers, right? Minus 1.1, minus 0.3, minus 4.4. In minus 1.1, minus 1 is the integral part. So both rint and round return minus 1. It's the same case as positive. Like in positive, it was returning 2 only, right? Which is the integral part. So now you tell me, in minus 1.1, what's the integral part? What's the fractional part? Minus 1 is the integral part, 1 is the fractional part, correct? Minus 0.3, minus 0.3, what's the integral, what's the fraction? Minus 0 and 3, okay. So, acha, I like to mention in this, you think that it just returns 0 because minus 0, like what is minus 0? But actually in Java, 0 and minus 0 are two different things. So when you are writing math.round minus 0.3, it's actually going to return you minus 0, not 0, okay? Because minus 0 and 0 are two different things. Minus 0 is defined in Java, correct? So minus 1.1, minus 1 is integral part, okay? And rint and round return that integral part, just like in positive numbers. So for numbers where the decimal part is less than 5, rint and round return the integral part, okay? Like understand this, it's not too hard, right? See, when you're taking a number like 2.4, okay, rent and round will return 2. When you're taking a number like minus 4.4, okay, rent and round will return minus 4, not 4, minus 4. This whole thing, not just the first letter, the whole thing with the sign, okay. Now for numbers above box 0.5, now what does this mean? This means, like suppose we take 2.6, 3.7, 1.8. Now what's the fractional part in this? 6. What's the integral part in this? 2. What's the fractional part in this? 7. Fractional part in this? 8. 8. 6. 6. Can you observe a general trend in these? That they are greater than 5. They are greater than 5, okay. So the decimal part or the fractional part is actually greater than 5, okay. So we are considering those numbers, okay. So 2.6, 3.7, 1.8, minus 1.8. Now you'll be like minus 1.8 is not greater than 5, okay. No, but actually I'm just talking about this part, the fractional part. I am not talking about the whole number itself, right? Okay. So now I divided into two cases for positive numbers, 2.6, 3.7, 1.8. And 2.6, 2 is integral part, okay, integral part. 2 is integral part, 6 is the fractional part. Now rent and round return 3. I mean, this is observed thing, okay. I didn't make the rules like this, okay. So when you feed this into rent and round, when you put this value in rent and round, then you will get the answer as 3. And so like I tried this with 3.7, I tried this with 1.8, and with 3.7 I'm getting 4, with 1.8 I'm getting 2. So now I apply my brains and I think, acha. So that means that rent and round generally return integral part plus 1. Now what does that mean? That means that if you take a number like example 4.7, so 4 is the integral part, correct? 4 is the integral part. So rent and round return 4 plus 1, which is 5. So what did I do? 4 plus 1, or the integral part plus 1, right? Integral part plus 1. And for same for negative numbers it goes. So like we have negative numbers minus 1.8, minus 0.6, minus 4.6. Then minus 1.8 minus 1 is integral part. So what do you think? What should rint and round return? You'd say that minus 1 plus 1 is 0, so it will return 0. Wrong. Actually, it returns minus 2. I try for minus 4.6, it will return me minus 5. I try for this minus 0.6, it will return me minus 1. Okay, so what does that mean? That means rint and round return integral part minus 1. Okay, so take an example minus 4.7. Now here the integral part is not just 4, it is minus 4, and the decimal part, the fractional part, is 7. So rent and round return minus 4 minus 1, which is minus 5. Okay, minus 4 minus 1 minus 5. Okay, basic algebra. So what did I do here? I'm just adding 1, actually subtracting 1 to be more mathematically precise, to the fractional, to the integral part. Okay, to the integral part. And here I am adding 1 to the integral part to get the answer. Okay, so this is for numbers above 0.5, like these. So now it's practice time. Math.round 3.2. What do you think will be the answer? So let's first of all identify the integral part and the fractional part. The integral part is 3, fractional part is 2. That means that it will return 3. How did I arrive at this conclusion? So if you remember, for numbers below 0.5, it simply returns the integral part. So here what did I say? Integral part is 3. So it will return 3. Simple as that. And is Math.round any different? No. Actually, Math.round and Math.rint are the sides of the same coin. Okay. They both are just doing the same thing. They're just rounding off the values. But they're two different methods because of some differences, which we'll see ahead. Okay. Now we get to Math.round minus 2.6. First of all, let's identify what type of a number is this. Is the decimal part greater than 5 or is it less than 5? The decimal part is greater than 5. So now we apply this rule, that for negative numbers, when the decimal part is greater than 5, we do integral part minus 1. So that means I will do minus 2 minus 1, which is minus 3. And same goes for rent. Now Math.round minus 3.2. So what's happening here? Here the decimal part is less than 5, correct? So it will return simply minus 3. Same here. Because that's how we did it here, right? It just returns the integral part when your decimal part is less than 5. So when your decimal part is less than 5, it is returning the integral part. But when your decimal part is greater than 5, it returns the integral part plus minus 1. I mean plus in case of positive, minus in case of negative. Okay. So here we got minus 3. Now coming to this example, 2.6. So here the decimal part is greater than 5. So it will return 2 plus 1, which is 3. Same goes for here. Now what about these two? So now we will understand how to solve this type of value where the decimal part is exactly 5. Right, till now we studied what decimal part, when it's less than 5 what will happen, when decimal part is greater than 5 what will happen. Now we need to know if decimal part is exactly 5 what will happen. Okay, to understand this, I'll consider an example and please pay attention to this one because it's a bit hard, right? So I open a bakery and this looks like a home. It's a bakery. Actually my home is just the bakery, fine. And two people come, you can see them, Champu and Nimbu. Okay, so these two people come. Now these two people are like very dumb. They have some different moods only. They do only two things. They either eat the cake or they throw it in the trash. Okay, so I give them two cakes, one which has icing on the top, one and another which has icing on the bottom. Okay, I just made the cakes for fun. I'm like, these people are dumb, they won't understand, let them eat whatever they want. So I made the cakes for fun. So you know what Champu does? Champu Champu eats the first part of the cake as well as the second part of the cake. Okay, for this cake I'm talking about right now. For this cake, he eats the first part. He also eats the second part. Champu. Okay. And what does Nimbu do? Nimbu, he eats this part. He eats this first part of the cake. This part of the cake, and he throws this part of the cake in trash. He's a very rude person, you know. You shouldn't throw cake in the trash even if it's bad. Okay. And in the second case, Champu again eats both the does not eat both the parts of the cake. Sorry, my bad. So Champu does not eat the cake. He just throws it in the trash. The whole cake. He just throws the whole cake in the trash. And what Nimbu does is again he eats only one part of the cake and the other part he throws in the trash. Okay. Now why did I take this example? Is it just a joke? Well, actually, Math.round and Math.rint work like Champu and Nimbu here. Okay. Suppose Math.round is Champu. Okay. Math.round. And Math.rint is Nimbu. Okay, now understand the deeper meaning behind this example. Now Math.round is Champu, Math.rint is Nimbu. Okay. So now I give Math.round a cake. And I will call this cake a positive number, and I will call this cake a negative number. The first part of the cake, okay, understand carefully. See, this cake is a positive cake, okay, that's just the name of the cake. The cake is a positive cake, and the first part of the cake I label it as odd. The second part of the cake I label that as even. Okay. Now, similarly in negative, I do the same thing. I call this as odd. I call this as even. Okay, the first part of cake is odd, second part is even. Now understand, okay. What does Champu do? For the first cake, that is for the positive cake, he eats both the pieces. Am I correct? Yeah. He eats the odd cake and the even cake. Champu. And what is Champu? He is Math.round. And I'll explain what this means. Just try to understand what I'm trying to say. Okay. What does Nimbu do? Which is Math.rint. Nimbu eats this part of the cake and he throws this part of the cake in trash. So he eats the odd cake but he throws the even cake in the trash. Now for the second cake, for the negative cake, Math.round, which is Champu. He does not eat odd nor even. He just throws it in the trash. He's like, get out. Throw it in the trash. So bad. I mean, my cooking is just insulted like that. Seriously. And Math.rint, which is Nimbu. He eats the odd cake again and he throws the even cake away. Okay. He throws the even cake. So here, what am I trying to tell you? Math.round is like Champu. Well behaved. Either he is eating the cake or he does not eat it at all. And Math.rint is a bit choosy. He eats either one part of cake and he leaves the other. Correct. So here I wrote the same thing. The first part of the cake is odd. The second part of the cake is even. So now let's understand with this flowchart. So now I take positive numbers and negative numbers. First let's focus on positive numbers. Positive may I can divide it into odd. I can divide it into even. Okay. Now in odd we have Math.rint, Math.round. Similarly in even we have Math.rint, Math.round. Math.rint, it returns the integral part plus 1. Math.rint. Math.round also returns the integral part plus 1. In even numbers, Math.rint returns simply the integral part. Math.round returns the integral part plus 1. Okay, now you'll be like, what is this IP? So let me explain again with my example. Here's the example, right? So now, what did I say? Math.rint returns the integral part plus 1. So you remember what Math.rint did when he saw the odd cake? He ate it up. So imagine that IP plus 1 means he ate it. So what will IP mean then? IP will mean he threw it in trash. So now let's go back to our example. Math.round and Math.rint. In odd numbers, let's just talk about odd numbers. In odd numbers, what did Math.round do to this piece of cake? He ate it. Am I correct? And what did Math.rint do to this piece of cake? He also ate it. So that means both these functions eat the cake when they get an odd number. Okay, I'll explain this. Just understand, okay? Now in Math.rint, in even numbers I'm saying. So let's consider this part. Math.rint, what he will do? He'll throw this part in the trash. Math.round, he will eat this part. Okay. We have to remember, right? Because Math.round ate this part and this part. Math.rint only ate this part and threw this part. Okay. This is in case of positive. So be very careful of that. This is in case of positive. Fine. And now we come to negative. Math.rint, it's choosy. Like it will only eat one part and it will throw the other part. It will only eat one part, it will throw the other part. And for each case, for positive and negative, Math.rint is eating the odd cake and throwing the even cake. So now let's get back to programming terms, because what is this cake and what is all this, right? So here I've drawn a number line to explain this. So here when we consider 2.5, okay, this is our example, 2.5. What does Math.round do? He eats the cake. Okay. What does Math.round do? For even numbers, he's eating the cake. For positive numbers, he's eating the whole cake. And eating the cake means that he is returning integral part plus 1. Okay, this is for positive. Eating the cake and throwing. Okay, so here what is Math.round doing? He is eating the cake, which means that 2.5 is becoming 3, meaning 2 plus 1, right? We are rounding off 2.5 to 3 in case of Math.round. What is Math.rint doing on the other hand? Math.rint is throwing the even part of the cake. He is throwing this part of cake, which means that he is just returning integral part. So 2.5 actually becomes 2. Okay. Now, in case of, we take another example, 3.5. Now this is an odd positive number, correct? Odd positive. In this case, Math.round eats this part, correct? Because Math.round the वैसे भी is eating the whole cake. So we don't really need to mention. Okay, so Math.round is eating this part. So what is Math.round doing? He is giving integral part plus 1. On the other hand, Math.rint is also eating this part of the cake. Because you remember, Math.rint through the even part ate the odd part. Okay, Math.rint through the even part ate the odd part. He ate the odd part, which means that he will return 4.0. So he will also return integral part plus 1, right? So that's why 4.0. So like for positive numbers, in case of even, Math.rint is Math.rint is returning integral part itself for positive even numbers, and Math.round is returning integral part plus 1. While for positive odd numbers, Math.round and Math.rint both are returning integral part plus 1. Okay. And now we go to this one, negative. So let's go to the negative side. Okay. So Math.round, remember what he did? He threw all the cake, he threw the whole cake in the trash. So what does that mean? What does that mean? Throwing means that he is just returning the integral part. Math.round. So now if you see for a negative even number, Math.round is just throwing the whole cake in the trash, meaning he's just returning integral part. And what is integral part of minus 2.5? Minus 2. Correct. So this Math.round will return minus 2. On the other hand, what was Math.rint doing? Math.rint was eating this part of the cake, throwing this part of the cake out. So that means Math.rint was throwing that part of the cake out, meaning he was returning integral part. So what is integral part of minus 2.5? Minus 2. Therefore, answer will be minus 2.0. Correct. Now for minus 3.5. Minus 3.5 is a negative odd number. So what is Math.round doing? For a negative odd number, Math.round is throwing the whole cake in the trash, meaning even the odd part goes in trash, even part goes in trash. And what does trash mean? Integral part. Meaning this is just going to return minus 3.0. On the other hand, Math.rint is eating the odd part, throwing the even part. And what does eating mean? IP minus 1. So he is actually doing minus 3. He is actually doing minus 3 minus 1, which is minus 4. So that therefore we have it like this. Okay, here's the graph. And now I wanted to point something interesting. See, Math.round 0.0 is 0. Okay, Math.rint 0.0 is 0. And you can apply the logic I taught you right now. For numbers below 0.5, it's obvious, right? It will be 0. But now there is an exception, or like a special case. Math.round minus 0.0 is 0. But Math.rint minus 0.0 is minus 0.0. Now the question is why? And even I don't know the answer. So like I'm keeping it as an open question. If any of you can figure it out why, please put it in the comments. Okay. And I hope your mind was blown today. I hope you're not feeling swoozy or you've not died in your chair yet. And thank you for watching the video. I hope your concept's clear. Thank you.